Tento projekt jako takový nemá obdoby v České republice. Je to historicky největší projekt z hlediska opravy dálniční sítě v České republice. Je to monstrózní projekt, protože nejedná se o jenom rekonstrukci a opravu vozovky, ale je to komplexní modernizace. Výstavba nové dálnice ve staré stopě.
Cílem bylo dostat dálnici do technických předpisů, které jsou platné v dnešní době, doplnit na D1 telematiku, hlásky, meteostanice, sčítače dopravy a podobné vybavení. Samozřejmě i podstatně zvýšit úroveň bezpečnosti.
Ta dálnice byla v takovém stavu, že bylo potřeba zahájit ty práce na, bych tak řekl, razantní opravě i hned. Pokud bychom čekali na povolení, na tu přípravu, rozšíření na 3+3, je tam obvyklá doba kolem 15 let. To znamená, dneska bychom ještě nezačali opravovat, modernizovat ani první úsek.
Tady jsme přesně na místě, kde začíná dálnice D1. Dokonce základní kámen máme přesně tamhle pár desítek metrů. Modernizace jako taková ovšem začíná na 21. kilometru. Víte co? Pojďme si celou modernizaci, celou D1 projet a cestou si řekneme.
Modernizace D1 je největší finanční projekt, který se teďka tady realizoval v rámci České republiky. Je to páteřní komunikace a tak samozřejmě i ta příprava a ta realizace a ještě k tomu za provozu, tak to byla zcela výjimečná stavba, kterou jsme teďka realizovali.
Byl to velký úkol, byť ne po té samotné, bych tak řekl, odborné stránce stavební, tam ty samotné stavební práce nejsou nic neobvyklého, ale to vypořádat se s nimi v daném čase a místě a to za provozu.
Co se týče délky stavby, modernizace dálnice D1, tak samozřejmě by se našly určitě místa, kde by se dalo ten čas ještě zkrátit. Ale i tak to bylo napnuto z pohledu technologického a pro mě kvalitativního důležitého velice moc, takže ty technologické přestávky byly využívány minimálně a ta stavba jela v maximální možné rychlosti.
V rámci modernizace D1 bylo položeno 900 000 kubíků betonu a jen tak pro srovnání, tak třeba to, co všichni obecně známe, přehrada na vodní nádrži Lipno, tak tam má 14 000 kubíků.
Tak opravdu obdivuju všechny ty pracovníky a skláním se před nimi, kteří zde dělají. Všem dělníkům za to chci poděkovat, protože to není o těch manažerech, o těch funkcích. Je to o těch lidech, o těch množství, obrovské množství lidí, kteří zde se na tomhle podívalo. A přiznám se, že mi mnohdy mrzí, jak veřejnost dokáže až hanebně kritizovat, dokáže hanebně nadávat těm lidem.
Jestli jsem někde poznal, co jsou to limity všeho možného, strojů, hlavně teda lidského vypětí, tak to bylo na modernizaci D1.
Pro mě to je opravdu srdcovka, protože jsem na tom strávil fakt 10 let života. Před 10 lety se mi narodila dcera a těch 10 let jsem se jí opravdu neměl čas moc věnovat, protože jsem jí hodně strávil zde právě na dálnici D1, aby se po ní mohlo po těch 10 letech opravdu plynule jezdit.
A teď je ta dálnice vaše.
So dear participants, we are approaching the end of our workshop and it is our last session, so embrace yourself. Well, just 4 presentations have left in the program. We've got a lot of presentations dedicated to culture heritage. By the way, mostly thanks to our guests from Italy, as always. And that's why we've decided to combine the final session, to combine BIM for culture heritage and for construction. And another key point, we're listening to many presentations these 2 days, but nothing about roads so far. So the road problems are here. And the first presentation that's I guess something new, because so far we've been speaking a lot about everything in BIM, so around BIM, so about accuracy, about completeness, details, and so on. And here is slightly different view. I mean, this presentation, because the title of the presentation is Application of RSA Principles to Improve the BIM in the Road Design Process with focus on the road restraint systems. And as I already know, RSA means Road Safety Audit. So the presentation will be delivered by Zdeněk Svatý from the Czech Technical University. So please, Zdeněk.
Thank you, Mr. Chairman, for a nice introduction. Yes, I think it will be slightly different than what we heard before, but I think it's not that far apart. I'm really glad that our last presentation we have heard in the previous session was for the railroad system and the BIM in that part. And what we want to focus on is the implementation of the BIM and its usage for the road infrastructure. I guess all of you know this, but I've got this slide just to determine where we are focusing and which parts of the BIM we are looking for. And for us, the big step up with implementation of BIM methodologies or the approach is with aggregation and putting all the necessary information together. So from that standpoint, what we are looking for is all the information which are necessary and important for all the participants, all the involved parties, and also about the processes, what needs to be done during not only just the design, but also the construction and maintenance phases of the life cycle of the building. And therefore, those are highlighted. And for the road infrastructure or the roads designs, we don't have that much issue with the visualizations, or we didn't have before. We are quite far with that. So that part of the BIM is not great advantage for us. But the big step up is with the aggregation of semantic information, of additional things which are in one common space, which can be shared and elaborated on, and especially the sharing of the information with all the involved parties. Unfortunately, as was already mentioned today and even yesterday, it's lagging behind the actual the common BIM which is used normally for the buildings. With the infrastructure, we are struggling with the IFC, with the formats, with the definitions, and it's a little bit problematic, especially here in Czech Republic, because now most of the big development projects and big infrastructure which are nowadays being planned and constructed, are mandatory to be in the BIM format, or at least partially apply this methodology. And that's an issue. One thing is that there's a slight difference when you want to apply the BIM principles from the actual buildings to the infrastructure. We've got the differences that the road is much broader. It's not focused on one phase with multi-level layering. We've got it on a large scale, so the GIS or GIS is important to also be incorporated in a proper way. And quite a lot of things differ from the actual building. So it's still not clear what data should be collected, who's responsible for them, and how they are utilized within the process, the whole life cycle of the building or of the project. And there's quite a lot of things which are interconnected throughout the life cycle, and those are problematic when we don't have the proper terminology, the corresponding standardization, which we are missing the crucial steps, the basic blocks on which we can work afterwards. And from the perspective of the road infrastructure, the safety is one of the main things which got to be also considered. And it's incorporated in the whole road life cycle in the very beginnings, when we got road safety audits, when we are checking whether the road is properly designed. The thing here is that we've got to consider also the drivers, how the road is perceived, whether if everything is clear. We've got to evaluate potential hazards which can be created throughout the design. And the consequences are much more severe here than the actual building. Like there's not many people dying just because you designed the stairs in the wrong way. But if you put some solid obstacle next to the road, because it makes sense to place some equipment on the road near to it, it can be fatal for the driver if he runs into it. So the road safety is assessed throughout the designing phases. And afterwards, when you've got the operation, the thing is that while it may not seem like it, the roads are designed to stay for a long time or long period of time, like 50, 100 years. You've got to renew the pavement, that's for sure. But the basic principles are still in operation. And quite usually, there are another safety elements and assessments made throughout the operational stage, where you elaborate, like if you've got some black spots, some place where quite a lot of accidents happens. And therefore you are doing some mitigations, some approaches, or trying to correct it in some way. And then you, of course, affect the layout of the road. And all of these information has got to be incorporated into that for the road administrator, for example, to be able to work with the newest version or the actual version of the road. And therefore, you've got to actualize everything quite a lot repeatedly. With the road safety, I won't bother you with that because it's for you, it's quite a borderline topic. For me, it's of course not. One of the funny things is that the WHO recognized it as a major global epidemic because quite a lot of people are dying on the roads, and therefore we've got the policies, and all the countries or in general states are trying to improve the road safety. And as I was saying, quite a lot of information parameters got to be considered. Not just the operational ones or the spatial characteristics of the road, but also the psychology of the drivers, the traffic volumes, how much cars are going there. Is it in correlation with how the road was designed, or we've got some increase due to new factory or something like that, new spot, which is like the source of new traffic. And also when you are evaluating, you cannot just look at it like on a simple building. You've got interconnection with the other parts. So when you evaluate, for example, intersection, you've got to take into consideration what's before or some adjacent parts of the road, if it's all in a relation. And there are quite a lot of approaches to that. The RSA, road safety audit, or we can have a road safety inspection, which is on already built road when we are trying to identify the problems and design countermeasures and remedy those issues, or we can afterwards, sometimes it happens that the remedies deals with the problems we identified, but create a new one. So we've got to make some kind of assessments. And all these information has got to be somehow incorporated into the information model of the structure. You need those kind of information. And if somebody is performing the safety analysis, he's supposed to get access to this kind of information. And maybe we can learn from that and use like some knowledge we got throughout the years to put it in a way that's implemented with the libraries, for example, that some kind of information, some kind of combination of parameters, when the designer is going to put them on the road and design the road, it's going to automatically warn him that this kind of combination of parameters leads to some kind of an issues. And that's an issue. And when we look into it, we said that, all right, that's a quite broad topic we've got to deal with, and let's try to find or try the approach on one of the aspects. And on every road, in every state, we've got road restraint system, guardrails, some things which protects you from fixed obstacles. So it's quite specific for our case, so we can go into greater detail with that. We can focus on all the aspects which got to be taken into consideration. And maybe we can use them and try to design the parameters or make it in a way that it can be afterwards easily incorporated in the BIM. Like what kind of parameters, aspects got to be considered when we want to use that. And when we look into the detail, there's supposed to be the IFC5, which should deal with the road infrastructure and all the objects and the aspects with that. That issue is that the level of detail there is depends on the software you are using and on the libraries. Usually the visualization is kind of basic and it doesn't allow further analysis which are necessary, for example, for the audit, for the evaluation of obstructed view of the driver or something like that, interconnections between various types of the guardrails, and some basic functional characteristics are also omitted as well. So we have decided that, all right, let's focus on one topic. And we have taken the highways and first-class roads in Czech Republic, small part, just over 4,500 kilometers of the motorways. And we said, all right, what kind of guardrails we've got there? And we identified 47 main types of the guardrails. And for these, we try to summarize all the information which should be incorporated in the libraries. What kind of information should be there, not just from the design point of view or the maintenance point of view, like the material or how long they are supposed to last, but also from the safety perspective. What's important to be incorporated so it can serve to all the users, and also they take our idea in the process. And for that, we have created so-called data sheets for every guardrail. We identify the main parameters, what should be there incorporated, and try to define those and to make it available for further implementation. Here's just a small example. So basically, you've got some photographic documentation of the general guardrail for this one specific type. As I was saying, we've got 47. You've got the plans, how they are supposed to be designed, what are the main characteristics, which are rather easy and can be easily implemented. But also there are some other parameters which are quite important. One of them is, for example, the level of restraint. What force or what weight, what type of vehicle we are able to stop. Is it just a concrete guardrail, or is it a steel, or is it just a wire? Something like that. So there are specific types and specific levels of restraint which are required for different situations. And for that, we've got to incorporate it into our data sheets and prepare it afterwards. Also, there's working with. There's an issue that you cannot just place the guardrail and expect it to work. You've got to have some distance from the obstacle you want to protect it from. Otherwise, when the vehicle's going to collide with it, it's just going to still collide with the obstacle as well, and the consequences are going to be severe, there's a minimal length. So some kind of conditions for applying of the guardrail. So the designer already have the first flag checked and it's prepared for him that it's going to be suitable. Because the thing is that if you miss some of those in the very beginning with the design phase, the further you discover that there's an issue, the more expensive it is. So if you prepare the parameters and the specifications in sufficient way, but not overly in complex way, it can make it easier and cheaper and more effective in the application. And so these kind of parameters we have tried to put into that. And the main outcomes, what we nowadays where we are, is that we have defined those 47 guardrails. We also want to extend, make it more extensive. We are working on more types to cover the whole country. But the thing is that the outcomes can be quite easily generalized. Like there's not much science into that. There's quite common shared types between the guardrails, or also in different aspects of the safety systems or the equipment. So you can take these principles and apply them to the wide range of other aspects. So we are trying to work towards that. We try to, or we already know that we're taking into consideration various level of detail, because sometimes you don't need all those at the very beginning, but it should be implemented afterwards. So that can be specified by the manufacturer, as we are used to with the classical BIM. Like there's no big problem. But the thing is that we are trying to encompass and put into consideration that the safety is also an aspect which got to be there, and it's more severe because it significantly affects how the road is afterwards changed and what's the development throughout its life cycle. Also, if we implement the accurate model for that, we can use it for example, the inspections or verifications where they are not obstructing the view of the driver, or another aspects which got to be considered. And the parameterization enables us to, for example, make the connections with other parts of the road. So we know which kind of guardrails are used in that region, or so from the maintenance part of or point of view, we are suggesting which should be implemented on that particular road to make it easier for the maintenance and eventually cheaper. And so we are trying to elaborate it a little bit, trying to apply it for other aspects as well, and try to show that these kind of aspects should be also considered. So in my conclusion, I think the transportation infrastructure is one of the critical parts. And yes, implementing of BIM is, I guess, necessary. It can save costs, can save manpower, can make everything more accessible. But if you want to apply it from the building, you've got to make the transition in a correct way. You've got to consider all the aspects which are unique for all the alternations. And therefore, we try to show the way how it's supposed to be done and what should be considered on a simple example of the guardrails. And thank you for your attention.
Thank you. Does anyone have any question, please?
I was expecting that.
I'm wondering how you are delivering the data sheets. You showed us on the slides a PDF.
Yeah, but
pictures, but
it's a database. So
what kind of
database? It's in the form of a database. So we've got the type of so far we haven't decided in the form how it's going to be handed out, because it was like the academic point of view. It was the goal what we are trying to get to. But while this research was done with cooperation with the Czech road administrator for the evaluation of road safety inspections to make it more unified, I guess. So all the involved parties know about all the information which are supposed to be there. So we are in cooperation with that. And the transition to some kind of library we made it in a way that it's possible, because we know that we try to define those parameters and those limits, but so far we didn't do it because we haven't found like the party to cooperate with. Or...
I need your business card.
All right.
And because we have a software for free, open source software, we just can publish exactly what you have done for free. You can just download it, install it.
That would be great, like to share the opinions.
Yeah,
we are open for cooperation, but that was the main idea, to show that there's an issue with that and how to solve it, because, you know, everybody can just say that there's the problem.
Let's stay in contact.
All right.
More questions, remarks? I have one.
Okay.
Probably it's a silly question, but anyway, don't get me wrong. You showed the road life cycle diagram. Yeah. Probably I've just missed out something. Is there any difference between road life cycle and classical scheme for building life cycle?
In principle, in theory, not that much. But in fact, if you build a building, you are usually changing the internal layout based on what for is the room used. For example, this is a presentation room, and maybe they will decide that it's going to be cafeteria. So there's going to be slight change, but most of the structural parts are going to be there the same. With the road, you've got two things which quite a lot affect how the road's going to look like. And one of them is the safety audit, because you can have, because there's quite a lot of accidents due to left turn or some improper design or some design flaw, or not design flaw, but some other aspects which couldn't be covered in the very beginning. And then you change the whole layout. And usually if you've got the BIM, you don't have just one intersection. You've got the stretch of the road over 100 kilometers. So the parts, integral structural parts, are changing quite a lot. And therefore, the maintenance phase is slightly different, because you've got larger changes there. And therefore, these kind of parameters should be there. Because the safety is straightforwardly changing the layout.
Thank you. Well, I realize
I hope that answered the question. If not,
I realize there's already discussion, but how do you think then, the last one? Could we consider geospatial monitoring as a part of safety?
Sure, that's one of the points I think I missed quite a lot, is that we are not taking into consideration the cooperation or the ability to aggregate the data or the correspondence between different databases, because we've got information about the traffic volumes, we've got the information about periodic monitoring and all these kind of things, which are not considered to be incorporated into the BIM. And if you want to take the BIM principles, they should be able to incorporate, or at least make it work with each other, to make the data available and in a format that they are acceptable to each other.
Great. Thank you again, Danny.
You're welcome.
Well, the second one presentation is just what I mentioned in my introduction. This presentation is about exactly the BIM about historical BIM, and what's more important, it's the first time that I see today the question of digital twins. So I would like to give the floor to Angelo Massafra. And his presentation is towards digital twin-driven culture heritage management, HBIM-based workflow for energy improvement of modern buildings.
Pleasure for me to be here with you today. Today I'm going to focus to present a piece of my PhD research that I'm carrying out at the Department of Architecture of the University of Bologna. And in particular, I present a specific topic of this research, and I want to focus your attention about a workflow that is based on BIM and also BEM models, that are building energy models, that we set up for studying the energy behavior of modern buildings. And I will explain what are modern buildings in our assumptions. and to study also some intervention strategies for the energy improvement of these buildings that could be driven by data, and so that could support the building administrators and building asset managers, for example, in decision making when they have to do some interventions. So, but I want to start by an introduction by presenting you some data about the impact of the built environment and cities on the climate change. We know that cities and more in general, the built environment, the urban areas occupy only the 3% of Earth's surface. However, they contribute to about the 60% of global GDP and the 70% of global carbon emissions and the 60% of world energy use. So it is a critical issue, and I think that all in this room agree with this same statement. So what's the start point for we engineers, architects, but also public administration, and I will focus on a building that is a public building, asset managers, what we have to do to solve these issues. I think that we can start thinking about the built assets and thinking about the existing buildings, because a lot of existing buildings in the whole Europe has low performance in terms of energy behavior, but there are also other problems such as the structural safety. Today I will focus only on the energy behavior. And this is a critical point if we speak about historical buildings, because all historical buildings in Europe require becoming more energy efficient, but especially in Italy, the place where I came from, the question is trivial, because we cannot intervene on these buildings with usual construction construction solutions, because we have to protect them. We have to respect their cultural, their architectonic, their historical values. So we have to find new strategies, and I think that that implement a system that is based on data and that could be implemented the consciousness, the knowledge, the awareness about these buildings, and we are moving on these topics. And in this huge framework, I know we are focusing on a particular construction techniques or particular buildings that are modern buildings. We in Italy intend modern buildings, or more specifically modern constructions. Those buildings be built in Italy, of course, between the 20s and the 60s. And they are very important because of this data, because they occupy about the 60% of the Italian existing buildings. So it's a very spread construction technique spread along all the Italian territory. And here you can see the main steps of these of the whole research that I'm carrying out with my PhD thesis. On the other hand, on the one hand, on this side of the slide, we have the problems that I show you. So a low technical performance of these buildings in terms of energy behavior, structural behavior, but also comfort behavior, and for the users that in everyday life are in the buildings. The need to intervene on this building, but while protecting them, while focusing also on their historical and architectonic value, but also on their strategical value, since they are public buildings that needs to be treated. And so we think that we need new business, new economical models, but new organizational models to reach the cost-benefit optimization on these buildings during their whole life cycle. So during, above all, their management, their maintenance phase. And we are searching in the world of digital transition. We are here for the same reasons. So you know all these potentials that digital transition in the construction industry, in the construction sector, but also for these for the building environment that they could offer. So an increasing accessibility of data, new data-driven procedures, new paradigms like digital twins, but also like HBM and artificial intelligence and so on. And low-cost technologies such as IoT sensors and so on. But we know that there are a lot of barriers, a lot of obstacles in this sector that we have to face, and also this is a quite complex problem. But I want to share with you some the general framework of the research. And here you can see this synoptic image of this research. So on the one hand, we have the physical twin that refers to the actual status of the building, so its history, but also its actual status, its current status, its state of conservation, for example. And on the other hand, we have our digital twins. There are a lot of definitions in nowadays of digital twins. I think that we can speak about digital twin as a virtual environment that could support us with data in the main phases of the life cycle of buildings. So for implementing the documentation, that is a crucial topic for the existing buildings and above all for cultural heritage, but also for implementing the conservation, the restoration or renovation, and the management of this building. And now I will show you in a very brief way our case study. Our case study is the building stock of the Alma Mater Studiorum, that is the University of Bologna in Italy. And it is a very significant case study, both at the building, but also at the city scale, because it has lots of buildings with a high architectural value. And you can see here some of modern buildings of the university, but we have also buildings, for example, medieval buildings, not only modern buildings. And it is a very huge because it has about 1 million square meters of floor area with lot of users and inhabitants. And this is the specific building on which applied the protocol, the method, the investigation method that I am going to present you. That is the Institute of Mathematics of Bologna. It was built by the Italian architect Giovanni Michelucci about in the 60s in the old town of Bologna, where there is the university area. And as you can see, there are a lot of functions related to the university life that the building hosts, such as offices, classrooms, laboratories, libraries, and so on. And the most important thing in this slide is that this building have a high U value, so a high low performance, both of opaque and glazed envelopes. And above all, this data, this red data, is that the building requires a lot of energy for heating during winter. So it is classified in the lower energy class dictated by Italian regulations. And here you can see the method that we set up to investigate the energy behavior of this building and support the conservation or the renovation strategies in terms of energy improvement. Today I will present the first 3 steps of this research, since the last one, that is the operational one, that is the more complex one, I know is currently under development. And as you can see, there are 4 different steps: the documental phase, the computational phase, the predictive phase, and operational phase. So starting by the documental phase, that is quite important for the cultural heritage, we defined this workflow that could be applied also on similar buildings, starting by an archival research about the building to know, for example, with the construction site documents, the history of the buildings, but also the stratigraphies of envelopes, and so hypothesize some thermal properties of the building, but also windows, window frame, window glasses, and so on. Then we performed a lot of in-situ investigation, and we tried to do a digital survey. That is this one. We performed this photogrammetric survey of the external elevations of the building and used it to compare with some drawings, some plans that the building administrators and in AutoCAD format. It was just an attempt, but we think that geometry in this case is important. But what is important, in my opinion, are the information requirements. So which is the information used for which we are modeling this BIM model, and above all, what is the level of knowledge that is a sort of, in my opinion, I think a sort of level of detail for cultural heritage to know the fidelity of the data that we acquired. So we performed this research, we continue by in-situ investigation, and then we started to produce this model that you can see in this video, starting to analyze the building energy model simulation, so to know the actual behavior in terms of energy performance of the building. So we tried this workflow to test the interoperability between BIM softwares and BIM tools and data more in general with BAM software that are building energy analysis. I'm honest, we had some issues and we have to manually solve some problems, such as, For example, you can see this roof on the main facade. It is flat in the BED model because there are a lot of uncertainties related to the geometries, but also we have to manually copy some data from the BIM model to the energy model, such as the climate data and the geographical data of the site. However, it was quite good to perform a pre-simulation of the current status of the building. Here, there is the last one phase on which I will present in the results at the end of this presentation. And you can see we defined 5 intervention measures that are roof insulating, facade insulating with 2 different materials that are B1 and B2, and windows substitution or integration. Then we combined these different intervention measures in about 12 intervention combinations, and we started to calculate the investment costs that are the costs required by the interventions, and we did it with through the BIM model, and we also calculated the energy demand of the building with a focus on winter and so on the heating of the building, starting by the BIM model that we produced through HBIM format and through the BIM model. And then this is the final result. I will show you in a more detailed way. That is a multi-criteria analysis that we set up to compare these different intervention combinations, this different intervention solution by an energy point of view, but also by the cost point of view, and so also by referring to financial point of view that could be very important for the building administrator. So let me show the results of this analysis. You can see the graph, the results on the right, and on the left the whole method. We should start here, just sum up what I was saying before. So intervention measures, 5 intervention measures. We combine them in intervention combinations, those one, and then we started to study 5 different parameters. So we have investment costs from the BIM model, then energy demand from the BIM model, but we also performed, starting by these 2 main parameters, the life cycle cost analysis. So we analyzed the energy savings that interventions could apport on the building in the next 30 years. And by this way, we studied also these two parameters that to be honest, revealed less important than the first 3, that are the payback period, that is related to financial issues, of course, of the interventions, and upgrade level of the building. And finally, we performed this multi-criteria analysis that is shown in this line graph. To have a comparison between different units that could be kilowatt hours or euros, we decided to scale all the values of this analysis in scores that goes from 0 to 100. So if, for example, you refer to a specific parameter that could be energy demand, if you can, and you choose an intervention combination, you can see if the value of energy demand is 0, maybe it is the worst interventions in terms of energy improvement of the building. And this, going to conclusion, allowed us to define 2 different strategies that you can see with these 2 different colors, that are strategy A, that is a group of the intervention combination that has high investment costs, low energy demand, and medium life cycle cost, and strategy B that is related to medium investment costs, medium energy demand, and low life cycle cost. So we compare 2 of these solutions with the actual status of the building, with the current status of the building, that is those in black. You can see the energy demand is quite lower for the intervention solution, but here there is a huge word that reads about the energy gap in building simulation. So please read this data to compare as a comparative and qualitative data. But we know that intervention solutions are quite good for our case study. Here we can see investment costs that are 0 for the actual status of the building, but that are very high for the blue value, and very quite low for the second value. And finally, the life cycle cost in the next 30 years, that is the most significant result, because we can see that by interventing on these buildings, we could also perform not only energy improvement of the building, but also we can help asset owners, and so public asset owners, to save costs, and so to save public money, for example. And I'm very rapid about this point. Here we are the future development of research. We want to implement digital twins for these buildings, and add to this static data, dynamic data that could be acquired through IoT sensors, for example. And we're dreaming about implementing these digital twins for 3 different reasons. That will be the energy model calibration, the energy saving with monitoring the dynamic data, but also for allowing, in a more general way, the performance-based management of this heritage. And this is my last slide that show you some dashboard that I'm developing to in a common data environment that relates the BIM model to the BIM models, and that could display not only with 3D models to the asset owners that could be more aware about their real estate. So, going to conclusion, I want just sum up. We set up this method that could be applied on new modern buildings of the Bologna, on new case studies, better. But we test also the interoperability between BIM and BIM softwares to open formats. That is still in its initial stage, also for our results. And we also produce some important outcomes that are the BIM models of the building that could be used in the future digital twins, and this multi-criteria analysis, that is a comparative analysis that could help asset managers in decision making. So I have ended with my presentation. I'm sorry for the late. I took about 2 minutes more, but if you have any question, I'm here, or you can write me by email.
So, dear audience, who has question, remarks? Okay, please.
Your input data are not totally sure, so there's an uncertainty in the input data. And of course, what you are anticipating is also not really clear. Have you somehow modeled the uncertainty in your model, so that you know how precise the prediction is?
The prediction, because yes, it is related to the level of knowledge, I think, because, for example, we have hypothesized the building envelopes, the building stratigraphies, starting by some historical documents, but of course, we could have performed some tests, some destructive tests on the building to know more the stratigraphies.
But also the prices, the heating costs, and the construction costs, there's a variance in the data. You do not precisely know it. This would be interesting. How
in fact, next to the development of research, I'm studying these in a more detailed way with dynamic simulation, dynamic energy simulation, because it was a static simulation. And but above all, digital twins could help in this, because with digital twins we could monitor the actual status of the buildings, and so what in concrete happened in the building. Because when we performed, this is a general topic, a general problem, when we perform energy simulations, energy models are affected by the so-called energy gap. Energy gap refers to the fact that I could, for example, hypothesize some functions that are hosted in buildings in everyday life, but my hypothesis could differ from the actual status of the building. So there is a gap that we need to study in a more detailed way. I hope with the digital twins that could be helpful for this.
Maybe a Monte Carlo simulation. That's always really easy to develop. Would be helpful here.
Well, so thank you again, and we are moving forward. So the next presentation should be delivered by Professor Paolo Fiamma from University of Pisa. He's not here in person, but he sent us his video, and if I'm not mistaken, he's online also. Am I not?
Yes. Hello.
Okay.
Good morning, friends. I'm here.
Okay, thank you. Now I'll introduce you. So, the presentation title is MENSURA est modus in RESBIM AEDIFICATORIA. Measurement is the construction mode via BIM. So my first question, of course, was how to translate the first part, but well, but thanks to our guests from Italy, they helped me to translate this. And by the way, it was figured out that Google Translator doesn't work for this case. The translation was really weird. Just check it out. Well, so the presentation is really attractive for me because it's about measurements as a construction mode. And since my educational background is surveying engineering, and by the way, as I heard, Christian is also has this background in surveying engineering, yes, too. Well, and so the surveying on the construction side is near and dear for me. Well, and it always appealed to me how to integrate BIM and construction side. And I guess in this case, we can, how to say, to coin the new probably definition, surveying management on the construction side. So I already know the team now. Your turn. Please run the video and then questions.
The BIM method allows to include topography and remote sensing in an important way, not only as a project before the construction, but also as verification after the construction. It is a continuous dynamic in itinéraire, not an ex-ante or ex-post approach. For a congruent design and a construction management, the BIM model must be made dual to the real. This dynamic does not only imply going from the virtual to the real in the smartest possible way, smart object-oriented, but it is also necessary to come back from the real to the virtual, always first of any next step. There is only one modus operandi to implement this BIM temporal iteration, measuring the built to return from the real to the virtual. The BIM model is modeled on reality. According to the computer graphics development, the reality returns to the model by measurements, also in automatic manner. Through the measurement, from the construction site, built object, you return to the model, designed object, in an active way. It is not only a control action. If the object is built in discrepancy with respect to the design, the BIM model must be modified or built again. Especially if the object was made directly in the building site, can be measured and check easy. There isn't need to automatically obtain the ontologies of the objects measured or scanned, necessary and expected, for example, in the research areas such HBIM. Case study, a public work. The Military Academy Italian Navy Headquarter Livorno. The first case study is the expansion and recovery of the headquarters of the Military Academy Italian Navy. It is an important project, more than 50 million euros, requested by the Navy and entrusted to the Ministry of Transport and Infrastructures, through the Provveditorato of Public Works of Tuscany, Marche and Umbria. For both institutions, this is one of the first cases of use of BIM, and they have requested the support of the University of Pisa. There has been a collaboration for years between the Provveditorato and the Master in Building Information Modeling of the University of Pisa, which has also organized BIM courses for ministry's employees. Our BIM research group is required to give support for clarify everyone's tasks and mediate the needs of professionals with the needs of the works management. The support was asked to us, regards both design and construction. It is necessary to measure the coherence level between the most important interests of the partners. For the publics, is the information specifications. For the designers, is the project presented. For the construction companies and the suppliers, is the management of their commitment. Based on our experience, measuring this level, during the progress of the work step by step, become essential. The whole situation is more complex, because in the project there are two parts. Some new buildings construction, and the recovery of the main old building, Palazzo Allievi. In addition, during the entire construction time, any academia activity can be suspended. Methodology. To meet the needs highlighted, it was decided to set up a BIM team, bringing together the different BIM skills of the professionals of the three public partners. The BIM team is a control room of the whole procedure, which must continuously support the procedure head. During the project, the team will interact with all the private partners about every BIM aspect. The second step was to clarify a workflow for the professionals of the public partners, according to the needs of their internal procedures, to the different tech competencies, and to the BIM software knowledge. We have suggested our vision and decided a customized management plan. We have considered the normal practice about the use of BIM for the public works in Italy. We have identified some critical aspects in this practice and proposed some solutions based on the concept of measurement as a verification of the BIM procedure and model. The procedure we have proposed can be schematized with the following sequence. 1. BIM executive model delivery verified by the designers. 2. Model checking by the procedure head of the public partner. 3. Model approval by both procedure head and control authority. 4. Model validation. Each BIM model element is linked to the acceptance checks, the measure of the built object, the technical data sheets, the reference drawings, the materials brought by the companies, which must correspond to the CI requirements, and every change introduced by the designers. 5. BIM model becomes official, uploading in a virtual environment editable only by the public partners. 6. Starting of the construction site. 7. BIM mode requested for any technical component changes proposed by the private partners to the construction management. 8. Under BIM team control, the accepted proposals are uploaded by the private partners professionals in the BIM model that becomes as-built version. 9. The procedure from point 7 is iterative. According to our procedure proposal, the BIM as-built model grows up step by step simultaneously with the construction, and everything remains under the control of the construction management. The general framework of our proposal was articulated on more detailed schemes. For example, there is a workflow scheme of the actors involved in the construction phases control. We propose a hierarchy between actors, building site inspectors, head of technical sectors, works direction, ever by univocal to the BIM model uploaded. In fact, to upgrade the constructions means to upgrade the BIM model and vice versa. Our procedure also answer to the public partners' request to avoid any physic overlap of the actors' competence, allowing, at the same time, to a continuous link digital between them and between their building site reports. Data management. Due to reasons of security, there is military institution, there are different needs for data management by each partner. We organize a multi-level responsibility plan. The public partners spend many times and economical resources to control the correspondence between the technical elements, planned in design, and which used in the opera. To avoid any mistake, we plan some professionals groups in order to management, easier, the building site works in progress, and the correspondent model uploading too. Our coordinated scheme of actors, software and workflows. It was not easy, because, generally speaking, in the public administration people having more building site experience have a limited BIM knowledge. How much BIM? The concept of measurement can be a way of implementing BIM because, not only it means exchanging data between design and construction, but also because it identifies the accuracy, the reliability, the quantity, the margin, the level of BIM, the modus operandi. The case study proves how the BIM management starts with the ability to identify how much BIM is needed for a specific work. This ability, it isn't an option, but it is an integral part of the BIM management process during the entire work construction. Identifying this level is the way of BIM. In BIM dimension, the link between design and construction is not only linear, but it is cyclical, and it includes also the concept of verification by measure. To sum up, the BIM process and model together is not a standardized or homologated method. Case study: a private work. In the second case study, an important private company asked our BIM research group to project a system to support the laid in the building site of their products, independently, by the construction company and worldwide. We can document how, in the application of the BIM method, there is not a cognition or practical problem of passage of scale from photogrammetry to remote sensing. The heart theoretical and practical remains the identification of the level of BIM ontology. It is ever necessary to be able to find BIM, tailor-made strategies and solutions to approach any situation, and to manage it day by day in the office, in the construction site, by remote, physically. The project proposal. The web app must have two levels that we could diversify into the manager user, UM, and the operator user, UO. To respond to these requests, we have created a BIM GIS system. The main elements are a web app and a coding reported on the construction elements during their fabrication. Usage pattern. The usage pattern is designed for two different users. One is in the building site, the user operator. The other one can be remotely, working in his office, the user manager. The user operator, with his smart device, accesses the web app, scans the QR code of the construction component in the building site, collects data, adds the geolocation, the time and date, sends the data he has acquired to the reserved virtual area of his user manager. The web app, in real time, loads a new line with the data that was acquired on site in the reserved virtual area of the user manager. The sequence we have setting for the manager user, generally working by remote. He asks for the activation credentials provided to him, accesses via remote PC, the reserved virtual area of the APP, and obtains the information that comes from the reading on site, via the QR code, in addition to the lot information, the GIS geolocation, the date and time of installation, the ID user operator. He sees the photos in the APP. He downloads the documentation of that component, identified by the QR code. From the APP, the BIM model of that component, the connected data and the information collected during the installation, he integrates his design project with this information uploading. The design offices of the companies, if work in BIM, can achieve maximum performance with the web app. Conclusion. The concept of measure as a way of implementing BIM. Using the BIM method, the concept of measurement was the base to verify the link between design and construction. Measure as physical verification and measure as theoretical verification. The first one must characterize, cyclically, the to-build-built dynamic. For this reason, margins of measure error about architectural, technical and structural aspects are foreseen in the core for tender. The second one is connected to the concept of BIM level, which becomes the core of the whole economical, technical and human resources management to allow saving costs and times. Both management of intangible and tangible assets depends by the manager's BIM mental dimension. The correct progress of the project is a consequence of the BIM management, which identifies, for example, the certainty margin relating to the quantities of supplies, and at the same time, the knowledge margin of the skills of the actors. A maturity of experience in the conscious use of BIM is documented by the use of the concept of measurement as a verification of the correspondence between what has been built and what has been designed. The first case study documents how different partners, using BIM, can act like a single team. The BIM model process verification, by an iterative measure, was considered a guarantee of correctness for the benefit of all the actors involved. We have observed that, in the constructive BIM approach, the concept of measurement can have really various levels. There is a measure of space, horizontal, and a measure of time, vertical. The case studies showed that these two measures are closely connected in the BIM we have used. For the reasons set out, we think that there will be more and more applications between the BIM method and the world of measurement, two areas of knowledge and research that have in common, as method and contents, transparency and clarity of conception and application.
Well, that's it, I guess, yeah? So, any questions? Please. Does anyone questions or remarks or suggestions? So, then I have one. Professor Fiamma, how do you think? In conclusions, you mentioned that measurements can have different various levels, yeah? And you mentioned just two, time and which levels do you think can be also except for time and dimension?
Yes, in this presentation, I speak about only two levels, but in the paper there are more different levels from an ontological point of view, practical point of view. And my opinion is, I speak about our condition, public work condition in Italy. The problem is not only use BIM, but if using BIM, we can have benefits. And this is strange, but in this moment is more like a fashion. And the measurement is a cognitive approach. So I think that the BIM method is something that go to the real and come back. But in order to understand the benefits, we need something that can allows us to say, okay, this is good. This I have already obtained benefits. So the concept of measurement is essential in this workflow. And I speak about two, the space and the time, because in a BIM, space and time are the same concept, especially from the public works point of view. It is necessary that we respect time scheduling. So generally speaking, the concept of measure is something that is related only what we build, but is another important point if we respect the measurement of the time too. So we know that we have a lot of tools and approach to control the space. But in my experience in public works, the concept of measurement is something that should be a dimension. This is my opinion.
Okay, thank you. Is there any question, please?
I would like to ask you because we have heard only about the iterative measurements. Yes, iterative measurements and comparison of the BIM model with the actual structure. Yeah, but I think that the BIM model is not only about the shape, yes, of the structure, but also about the properties of individual elements or construction elements. Yes. So, do you mean that this is also as a part of the BIM and it should be compared, yes, the planned, yes, elements and the actually realized elements, yeah? Yeah.
Yes, of course. I think, as you, as the same approach we find we need in the practical approach of BIM to have feedback to understand if what we put inside the project, I mean design, construction, and management, is correct. So this level of should be an object of measurement of measure 2. So in the paper is explained a little bit, but the concept is that we must have a feedback about all what we put inside the model. So I need control what I put during the process product, and I can measure everything. Different level of meanings, of ontologies, meanings. The problem, the issue of the control using BIM is the most important in the public works now in Italy, because we have only one law about BIM, and this law is not, I can say, a procedural law. It's just some suggestions. So what is important, I repeat, in Italy, from my opinion, we work with some ministry too, is to understand the level of measurement of what we say that BIM can do. So, for my opinion, we should find a way to measure all the data that are not only physical.
Okay, thank you again for your participation.
Thank you.
Well, we're getting back to the roads, and the last presentation for today, the last in the program, but not the least in the content, of course. Don't get me wrong. This presentation is digitization in road construction, automation of as-built models. And it seems that theme can be thought of as BIM for roads, I guess. So the presenter is Heinder de Winter from Leuven University, Belgium.
Hello everyone, I'm Heinder de Winter. I'm a PhD researcher at KU Leuven Technology Campus Ghent. This is a research group, like I said, I'm from the KU Leuven situated in Ghent. Our research group focuses on 3D reconstructions and measurements, and we do some analysis and interpretation of these recorded data these are some recent projects from us. I'm busy with the digitization in road construction, and my colleague told you about the scan to BIM. The problem in the road construction is that it's little digitized, and my project is about to automate some things in the road construction. So the first thing is to capture remote sensing data. That's on the left side of this picture. It's about I use RTK UAV. The next thing is to extract information from these georeferenced outputs, and the last thing is to interlink and exchange BIM. So the methodology exists of two major parts. The first part is to exchange ensure homogeneity, to provide the basis for automatization. That's using some specifications that is it's provided by the local road agency. And the second part is to automate georeferenced outputs from an RTK drone. The purpose is to start from an execution BIM and to go to an as-built BIM by using detected objects from these automated different outputs. In this paper, I am just I'm going to manually detect them, but it's purpose in future research that it will be automated. So the homogeneity of the data is important to provide automation in the future. There are some specifications like level of geometry, level of development, and level of information that is needed, and it's different in the execution phase BIM and the as-built BIM. Periodically, the execution phase BIM should be adjusted to the as-built BIM by periodically flying with the RTK UAV drone. The both models are linked with the AWV OTL. It's an object type library of the Flemish road agency. So these different outputs are currently already automated. I start with the RTK drone. These are uploaded in the Metashape software, and then the problem is that Metashape doesn't support the Belgian coordinate system, so there is an external transformation that is used to take the coordinates from Belgium. It is with the selection list because there are two different coordinate systems in Belgium, and then some outputs are automated from that, like a digital elevation model, point clouds, meshes, and so on. Then I did some experiments. First experiments was to test the accuracy of the RTK drone. First of all, I tested some different markers because they have to be detectable from the height in different weather conditions, and they have to be durable throughout a whole project. So with that experiment, I found out that 3D printed targets are the most durable and most detectable targets. Then I put them in the test site to test the accuracy. So these markers were measured with the drone and also with the GNSS sensor. And in the paper you can see the accuracy, and then you can see it's quite the same like a GNSS sensor. So ground control points doesn't need to you don't have to need ground control points when you're using RTK drone. Some other experiments, I had a test case. From that, I choose 3 objects to manually detect in order to see if it's possible to, in further stages, to automate them. I choose sewers, subfoundation, and manhole covers. These are accuracies that are provided by the Flemish agency. Also when the accuracy isn't reached from these objects, they have to be changed from the execution phase BIM to the as-built BIM. The hypothesis of the sewers were to detect them on geolocated images. There are three different distances, and you can see that distance 2 is too big for the required accuracy. So this sewer should be relocated in the as-built bin. Another detection was the subfoundation, but the subfoundation wasn't finished yet in this test case. So the hypothesis was to detect them on a mesh. Right now, it's not possible. I don't know if it's not possible because it's not finished, or if it's not possible on the mesh. So that should be future research. The last one was to detect manhole covers. There were 3 manhole covers in this test site. The bottom one was already finished, and the two above were not finished. Because these manhole covers weren't finished, the altimetry cannot be controlled, but the planimetry can be controlled. So that was from the 2 above, and the bottom one, all these accuracies could be tested. And like I said, when an accuracy has not reached the as-built BIM, should be changed from the execution phase BIM. So the conclusions of this paper is that ground control points are not necessary when you use an RTK UAV drone. That I did some manual detections on some objects, so an automation should be possible. And I started a point from the of the linked data pipeline by the homogeneity of the data that I started doing. So thanks for listening.
Well, thank you. Has anyone questions? I see we have here everything. We have drones, GNSS, orthophoto. So, Zdeněk, you do have questions because it's road. Please, Chris.
Thank you. How does the object type library you talked about, how does it really look like? Do you have the objects like Revit families in it, or is it just the semantics, the OTL you talked about?
Yes, that's something that the Flemish Revit Agency just started doing. It's like just introduced in 2021, I think, and it's still in the test phase. It's not a Revit family, it's a semantics.
So no geometry, but very similar to what we have heard from the Czech Republic. Yeah.
Yes.
Okay, interesting. Thank you.
Any questions more, please? No question. Thank you. No, thank you. Well, as in the famous thought, time to say goodbye. Yeah. Well, and oh, it's much better to deliver presentations without microphone in hand. Well, the agenda of our workshop is used up. I would like to thank all the participants, both who attend our workshop in person and those who were online. Our scientific community, as I see, is growing, and it's better to let's upload ourselves for a great job, I guess. Yeah. Well, I've made some remarks just to don't forget that I want to say. So first, your papers are already published. If you know, so you may find them at the ISPRS website. There have DOI and so on. And from my experience, it takes up to 2 months. They will be indexed in other databases and so on. Well, the next is the best paper awards will be announced a bit later, as well as the journal and the special issue of the MDPI, where you can publish your results. And we have agreement with MDPI that the papers that will get the best paper award will be published with some discount. You know this procedure, yeah? I think. Well, okay, please follow us on our website and social media, and we hope that the next workshop presumably will be in Almaty, Kazakhstan. So now it's already safe again, safe place and nice people. So I guess it will be there. Well, and again, I would like to remind you about ISPRS Congress in Nice, France, that will be held in June this year. So me and Karel, we're encouraging you to participate in our forum, Education Towards Digital Transformation. And you already know that it's not just about education. It's mostly about BIM, construction, architecture, fusion with surveying, etc. for education. That's probably much better definition for our forum. So please join us. And you know that I showed you yesterday that there are many topics, miscellaneous topics in BIM studies for this forum. Well, I guess that's it. Good luck. Take care and see you next time. Right? But don't run away. By the way, the lunch is waiting you in the lobby. And the last announcement concerning for those who want to participate in guiding tour in Prague. So Adam, probably people who wants to do this, please come up to Adam, and he has the contacts and the information concerning this. Now that's it. Thank you.